What happens when we create machines that are as or more intelligent than we are? What are the possible timelines, implications, and ways forward to ensure we create the most positive future for our world? In this episode sequence on responses to AGI, we look at how people and organizations around the world are responding to a future with more capable AI systems and how we can look to more effectively ensure a safe and positive future for humanity. This is the AGI show, and I'm your host, Sarush Paul. Today we speak with Ryan Kidd. Welcome, Ryan. Great to have you here.
Thank you.
Ryan is the co-director of the ML Alignment and Theory Scholars Program, better known as MATS. MATS is an AI alignment researcher training program that sprung out of Stanford and Berkeley's respective existential risk initiative programs. So they had both had one of these, and through a joint program, MATS was born. And they work, so the existential risks initiatives, they work to ensure like the flourishing of humanity in the future. So avoiding existential level risks that would kind of stop us continuing to progress in the way we have these last centuries and millennia. And MATS specifically, as part of their programs, is focused on AI safety. So the risk from future advanced AI systems. And so MATS provides seminars, research mentorship, and connections to help new upcoming AI researchers get established and to start to work towards impactful research in AI safety and alignment. Before becoming a director of MATS, Ryan did his PhD in physics at the University of Queensland in Australia. And the reason I want to bring Ryan onto the show today and to kind of learn more about MATS is we know we have a lot of audience members here who are concerned or thinking about the future of AI and where it's going. And one of the ways you can contribute to a more positive future is by researching safety directions and other techniques that we need to ensure a positive future. So MATS is a great way to get started, and we'll get Ryan to talk about kind of what MATS actually looks like and other the specific research directions and other initiatives that MATS and Ryan are aware of in the space. Awesome. So great to have you on the show, Ryan.
Awesome. Thanks to be here.
Yeah. Awesome. So we'll just start with Ryan. Do you want to just tell us a little bit about yourself and your work?
Yeah. So unlike a lot of people working on AI safety right now, I didn't start in a machine learning background. I started doing physics. So I grew up on the Gold Coast in Australia. So I was born in the US, moved to the Gold Coast when I was 5, grew up there, and went to school on the Gold Coast, and then went straight to Brisbane for university, where I did UQ Bachelor of Science, majoring in physics, an honors year, eventually a PhD with Professor Joel Corney. With Dr. Joel Corney. And during that time, I became quite aware of the accelerating pace of AI technology. And I became aware of some of the arguments that this technology was not necessarily going to turn out all right by default. It might actually need a lot of work in order to make sure that it actually benefited humanity in the way it was intended. And I discovered this partly through the university's Effective Altruism student group, which was founded sometime in 2017. And I was involved in that for a while. And then during that, I read The Precipice by Toby Ord, which I still think is one of the best introductions.
He's an Oxford professor?
Yeah, an Oxford professor. And I still think that's one of the best introductions to this whole existential risk space, because it addresses so many different moral perspectives you might have towards this issue. And it also is a pretty thorough representation of the space of X risks as we still understand them today. Right. So it includes everything from quantum vacuum collapse, where somewhere in the universe, maybe we're in a false vacuum and suddenly it drops to the ground state and it spreads like a virus at the speed of light to destroy and annihilate everything in the universe.
Really hope that's not one of the risks that we're facing. It could be. Somebody's researching.
Maybe it is. I don't know.
Yeah.
Toby certainly thinks it's very low probability. I think I share that belief, but it's not impossible.
And you are a physics PhD, so that gives me some hope.
Cheers. Through to things that were more conventional risks. I was a big climate change activist. I was involved in a lot of door knocking for the Greens party in Brisbane, because I was man, climate change is a big deal. The Greens in Brisbane seem like they know what they're talking about. They're actually pushing for federal policies that would make a difference. So yeah, that was a big deal of mine, as well as when I was like younger student, I was very into climate change activism and Amnesty International as well. And I think like out of these kind of motivations and this kind of interest in improving people's lives, people living today, people in the future, and you know, like leaving the planet and also like our just legacy as a species, including possibly, we don't know, maybe the only species that is like at the level of capability and sentience and conscious experience in our local group, or who knows, even wider. There's a lot of interesting papers on the Fermi paradox lately that I would recommend I could discuss later. But yeah, I think it's very important that we like do things right. And we might not, like if we do things very bad, you know, this might not be recoverable, you know? And it was
And I
these
guess
motivations.
this is what that whole existential risk initiative programs are looking at, like just in general, what are the things that could stop us from flourishing, not just AI safety, but these other things.
Yeah, and I think for me, so the reason I pursued a physics PhD and didn't go into, say, climate science activism was I was like, this concern seems important, but it seems like very hard to make a difference as an individual here. Most of the difference seems at the level of corporations, government, etc. Conceivably, I could have pushed for that, but I was also a bit selfish. I was like, I really like physics. This is very interesting. And I was like, I could maybe do
There's
something later.
often some tension between these things, right? There's things that we want to do for the world, but also we need to actually get excited by it and be interested in it. And we always have to find the intersection of those two things.
I agree. Yeah, I think there's this, you know, that's the nice concept of ikigai. You know, the Japanese words like, what can you do that the world will like, that you'll get paid for, that the world needs, that you're good at, and some fourth thing I forget. But yeah,
Sure. We'll share the Venn diagram with the ikigai in the show links. Yeah, it's a great one to kind of remember when you're thinking about career planning and things like that.
But I think what's interesting from this concept was, I don't know if I'm particularly good at what I'm doing compared to maybe the best person I might hire if I had money or something, but I'm very motivated to do it. And there's not a lot of people working on what I'm currently doing. I think this applies to AI existential safety more generally. I think this applies to like both to what we'll call accident use, that is to say like AI run amok, and malicious use of AI. Both of these cause areas are extremely, I think, under invested in terms of man hours, especially like very talented person hours that could be, you know, could earn a lot of money. There's a lot of people out there earning a lot of money right now who could instead, you know, be trying to solve some of these problems as well.
Absolutely. And remind me, were you part of the founding of the MATS program, or did you join just after?
I joined just after. So the MATS program was started by two Stanford students, Oliver Zhang and Victor Warlock. Oliver Zhang is now working operations at Dan Hendryck's Center for AI Safety that published that Future of Life, the successor letter, I suppose you might say. It's the Future of Life Institute letter, the letter that said like,
the
it's like one
statement
sentence.
of existential risk,
AI is an X risk and we should care about it, signed by
which had like
virtually
Jeffrey
everyone.
Hinton and Joshua Bengio sign and others.
Everyone but Yan LeCun.
Well, that's yeah, okay. Yan LeCun might disagree that there's everyone but Yan LeCun, but he was a notable exception.
That's true. He would probably disagree. I have seen competitor letters come out since, and I'm like, the people in these letters, some of them are quite distinguished professors and stuff. But I'm like, I think the signatories to the case letter it's quite profound that so many of the luminaries of the field are, you know, thinking that AI is an X risk.
Yeah, and the CEOs of these companies, which people have tried to come up with all kinds of odd explanations about why they would sign, but the fact that CEOs of companies are saying our product could be the thing that ends humanity is a pretty big deal and pretty unique in the history of business as well, I would say.
Yeah, I think like there's certain people on Twitter who like to claim, or X as it's now known, they're like, oh man, this is like regulatory capture, and I'm like, that is totally plausible. That's totally a thing. That might be.
I might disagree with the level of plausibility, but yeah.
I just like it seems like the most backwards, ineffective way to approach regulatory capture I could see. They're like, oh, my technology has the power to destroy the world, and therefore you should invest in my company, you know, and we should be the one. When I look at the actual regulations people are trying to push through you know, various like think tanks like RAND, etc., and IAPS, which is a new one, they're like very restrictive of the frontier labs like Google, OpenAI. Anthropic.
And some of the things that people, the other signatories on that letter are pushing for are like even, incredibly critical of these labs and stuff. The idea that they all got together and agreed on something says something quite unique as well, I think.
Yeah, I think so too. Yeah, I think it's like pretty astonishing actually that you have. I'm not going to like pat the labs in the back or anything, because I do think like in some way they're part of the problem. It is very complicated, and we can unpack that later maybe. But I think it is like commendable that they've hired people who were outspoken critics of labs to like help them build governance policy solutions. You might also, like, skeptical viewers might be like, oh, they've like hired the people who disagree with them to silence them. But I don't know, like I see a lot of the work coming out of, say, the OpenAI governance team, for example, is actually pushing for quite strong regulation on the capabilities of frontier models, or at least like quite strong safety guarantees. And I think that's very important. I think the fact that OpenAI and Anthropic opened up their models, ChatGPT and Claude, to inspection by ARC evals, which is the Alignment Research Center evals team.
Right. Which is an independent, not-for-profit, separate to the orgs.
Yeah, which like as its founder, Paul Christiano, who was basically one of the co-inventors of reinforcement learning from human feedback, which makes these language models today palatable, marketable. But he left OpenAI specifically because he thought he could do better work outside of it in a research nonprofit, and founded ARC. And ARC evals is now is led by, it's a separate kind of offshoot that focuses more on evaluating systems more than the kind of theoretical safety guarantees that Paul's working on at ARC Theory. But ARC evals is like, let's like test the behavior of these models. Let's like put them in a bunch of weird scenarios. Let's see whether they can, solve CAPTCHAs or like get human task rabbits to do that.
Things that might end up being used in a some sort of risky scenario involving AI.
Yeah, you could imagine that if someone, like, either you could have a malicious actor who takes an AI, is like, hey, help me build a botnet. And as part of that, the AI has to do like a bunch of hacking, or it has to like pass some sort of air gap process and hire people to do that, or hack through firewalls, et cetera, et cetera. You can imagine that like the kind of evals that ARC evals are looking at are trying to assess how dangerous models are on some of these dimensions, and also like to what extent have the safety features labs implemented managed to actually address some of the key concerns.
How much does it stop these things? And they do a lot of really good quality. And you're right, the fact that the labs allowed this to happen and prior to any regulation, and kind of did this out of their own desire for safety is a really good sign.
I mean, I think it benefits companies if they have a product that is robustly safe. I think like that if, like, for instance, airlines, right? It benefits airlines if all passengers think that airlines have a very high standard of safety, and airline safety is like phenomenal. It's and this kind of like, there's this kind of you can imagine like a weird race to the bottom if all the labs were somehow, I don't know, if the regulators were like just like a box you had to tick. You just had to submit some regulator, and then some new regulator gets formed, and they just like help you tick the box, and it's like a race to the bottom in terms of like who's the cheapest regulator to pass.
Rubber stamping, or who's the cheapest politician to pay off, or
safety washing.
Yeah.
But I think in fact there are strong incentives to have really robust evaluations, even from like the level of product. Though I don't want to rely on this.
Yes, and exactly, and there's, you can both be. I think you can both hold the idea that the labs care about safety and are doing positive things for safety, and still also believe that we need to do more. That those two things can be things we can hold both true.
Yeah, I believe in defense in depth. Putting redundant fit like barriers, like the Swiss cheese model. If you stack enough layers of Swiss cheese, eventually you can't see through it.
Have you tried this at home?
I may have tried this at home.
Ryan, do you think it is possible for us to create something resembling AGI, something that can do all of the things human beings can do, or the vast majority of things human beings can do? And what do you think that future system might look like? What does that future with AGI look like?
So I will say that I do think it's possible. I do think the computational theory of mind is probably true. I think like that the mind is like the human brain is a computer. And I put relatively low credence in arguments that are like, oh, there's some like wet quantum thing happening, or there's like some like extremely substrate dependent
Right, something where like if
processes.
it doesn't look exactly like this analog neuron biological thing, it just won't work.
Yeah, I find it hard to believe that this would be the case. I guess part of this is something like, I mean, obviously, like decoherence at large scales, renders like most
This is
quantum mechanical
decoherence in the
effects.
like quantum theory
Yeah,
context.
quantum decoherence at large scales
You're
renders
gonna have
most
to
quantum effects.
explain that for I don't think we can assume that the audience members will know what you're referring to here.
Oh, just long story short, basically, the reason why we can have like theories of physics that don't like require like weird understandings that like particles are present in multiple locations at once simultaneously with like some 50% probability here, 50% there. They're like in a superposition. The reason we don't need to worry about this at large scales, and we actually have theories of physics that are effectively true at large scales, at least like as far as classical physics is concerned. I won't speak about general relativity, quantum intersection, because I'm not an expert on that, and that's extremely unknown. But the reason we have these physical theories that work is because this phenomenon called decoherence, where the quantum properties basically get washed out at scale. So I don't want to go too much into this. I know Roger
They just
Penrose
stop
has some weird
mattering
arguments.
these quantum effects at some scale.
Yeah.
Does that scale actually apply to the scale of neurons and brains? Like, what are the scales at which they, these washout effects happen?
I don't know, like a few 100,000 particles, like you're already in quite a classical
Particles as
regime.
in like
Atoms.
right.
Yeah, like it's that, and there's like huge number of atoms. Like even in, yeah, I think the more I don't want to straw man this kind of like computational substrate argument, because I think that there are interesting arguments from the perspective of like gated ion channels and all these kind of things, like in neuronal synapses and how they fire and stuff. Like if you were trying to precisely computationally model like a synaptic potential and like all the various kind of like the sodium ion channels and all these things that occur as part of the process of like depolarization, repolarization, and then the firing of action potentials down axons and reception by dendrites, and then the diffusion at the synaptic cleft of all these different compounds. Like you end up with this like incredibly complicated model. So the question is like, can this be reasonably approximated? And by the way, I'll say there's two things here. One, if you were trying to digitally model a human, could this be reasonably approximated by some like maybe like could one neuron be represented by like maybe 10 to 100 neurons? And if anyone is interested in arguments for and against this, I recommend they read Ajay Kocher's biological anchors paper, which goes into this in quite some depth and is interesting. I think this is quite plausible. And the second thing I'll say is that like even if it is implausible, I think it's very plausible that the algorithms of conscious or just like, I wouldn't say consciousness is the special property here in terms of like accomplishing powerful tasks in the world, but it might be. But the thing I want to say is that the algorithms necessary to be like an agent to like outcompete humans at a huge variety of games. And I'll say games because that's kind of how I'm conceptualizing everything from playing Go through to winning elections, or having like making good trades in the stock market, or being a great CEO. I think that these algorithms are very possibly like it's extremely likely these are representable in the kind of AIs that we're building today.
Yeah. And I think that while there are still a lot of discussions and debates out there about how the brain works and how we achieve the cognition, the intelligence that we do, one, the simple fact is we don't understand them. So I don't think we should be overconfident that we couldn't, that it's implausible that we couldn't create it somewhere else in some other substrate. Like, I don't think we know enough to rule it out. And then secondly, we're just seeing too much progress to ignore that progress in the artificial intelligence realm, right? If it's one thing if, it was one thing to be making these arguments before GPT-4 existed, where you could say, oh, well, we just really don't see any good examples of artificial intelligence that's not this really rudimentary, rules-based logic, the way a calculator does things. But, we've had kind of generation after generation beat all the benchmarks and all of these capabilities that we thought were only available to humans and are only available to the types of brains that we have, and we're just seeing those walls get knocked down. So it would take, I don't think it's incredibly plausible that we can build general intelligence in new substrates. And in fact, we seem to be on that march of progress right now, watching it live in the technological realm already.
I think so. I think there are strong arguments. Like there's a paper on like the Chomsky hierarchy, which discusses like some types of tasks that transformers, the current paradigm for deep neural nets, that is like having such success in language models, can't accomplish. But as soon as you give transformers access to structured memory that they can manipulate externally, that obviates this paper's whole central thing. Yeah, well, basically the thing this paper might imply. And if you build like auto GPTs, like there's auto GPT, baby AGI, these little
these like
Twitter projects,
agent loops on top of LLMs.
Yeah, so there's an interesting paper, like a review paper I read recently. It was just, I can't remember the exact name, but it was summarizing a bunch of the progress in using language models as like central controllers. Like you could imagine a global workspace theory of consciousness. Your language model is like the conscious like the kind of controller, and has access to a bunch of tools. And they could be like scratch pads or just other maybe specialized versions of itself, mixture of experts type stuff, or who knows, like web search, etc. Then this thing, like this might resemble the way our brains actually function. And I guess I'm like scared that this is happening already, that open source models in particular present a very viable pathway for progress in this kind of auto GPT stuff. I could imagine that if all it takes is like a bunch of hackers, trying to make better and better auto GPTs to unlock, some seriously powerful agents, this is like quite scary. One way to like accelerate that process might be to do what Meta is doing and like open source their language models. I don't think this is good. I think open sourcing AI systems is probably extremely bad for this specific reason. And yeah, I'm pretty worried about that. I think that when I've talked to people at the labs, I think they're most worried about like if they're imagining like how would we build AGI if we don't learn anything fundamentally new, it would be something like in 10 years or less, maybe like 2 to 5 years at minimum. We have language models that are sufficiently big, and we put them in the right kind of scaffolding in terms of these tools they can access, and they're fine-tuned to use these tools and to accomplish a bunch of real-world tasks that are kind of complicated. And maybe there's a lot of human feedback in some of these tasks. Maybe eventually there's some sort of self-supervision where you have versions of the models compete against each other. And this makes models very powerful, potentially. And I think people are right to be afraid of this picture.
What are your thoughts on, especially with the open source models? There's a lot of people where as soon as you mentioned, not open sourcing these models, they have a gut negative reaction to that, for critiques like, well, that just locks up the power of these models with these large corporations like Google and OpenAI, rather than letting the rest of the world use them. It also locks up the benefits of these systems, for everything from health to education to other types of research. So what are your thoughts, to those kind of critiques around not open sourcing or keeping these big, powerful models closed source?
Yeah. So, I mean, there are, I think, two kinds of critiques, and some of them are like, one is sort of like, man, open source seems really good at making things robust and safe. Why not open source it? And the other argument is, like you said, people are like, well, you're discouraging innovation. These are obviously both true, in a sense, but like they rely critically on the safety and I guess like progress trade-off being good, and I think the analog I want to look at is like the kind of gain of function research done on very dangerous, pandemic pathogens. I don't think that everybody should have the capabilities to do this, even if this would result in vastly increased, retrovirus vaccines or something.
Right. Even if there's some benefit, if the risks from during the development phase or during the deployment phase are high enough, then they may not be outweighed.
Yeah, I think it is a trade-off. Like, I think it'd be crazy to argue that, oh, in fact, it'd be crazy to say making models, preventing open source large language models above a certain size is, in fact, not bad for innovation. It's obviously bad for innovation.
Right.
What
No
we're scared
one's
about-
arguing that there's no benefits here or there's not a loss. It's just they're weighing it up against something else.
Yeah, they're weighing up the benefits of like open access innovation against what I'll call the unilateralist's curse, which is where if everyone has access to a technology that can harm everybody, then you are at the mercy of the least careful person among that group. And as we know, there's a lot of people in the world who aren't very careful or are even actively malicious.
And on this point, I think a lot of people then think about domains like cybersecurity, where open source has been very good for making systems more robust. But I think one key difference there, because I think about this a lot, and there are some things we should definitely open source, but what makes it different there is like you actually have to have a defensive method. You have to. So when someone finds a 0-day vulnerability, people can go patch that quite quickly. It's like usually pretty easy to see the fix once you see the problem. Someone goes, "There's a hole in this code. There's a buffer overflow," and then somebody goes, "Okay, cool. I'll change this code," and now buffer overflow is gone. And so releasing that and everyone patching it is a really good thing. With these current systems, when we find a dangerous capability, for example, it's far from obvious how we actually neuter and remove that capability in a way that's actually now safe for the world, like robust for the world. Neutering it doesn't mean that the malicious actor doesn't have access to it. Neutering it doesn't mean you haven't found like a related but harder to patch vulnerability with these models. So yeah, it's as defensive as cybersecurity people would say, offensive defensive symmetry does not seem even in some of these risk scenarios that we're talking about.
Yeah, there's so many directions I could take this. I think the thing I'll say is like, I think the offense-defense balance for cybersecurity is an extremely poor model for the offense-defense balance for AI systems, because the offense-defense balance for biosecurity is really bad. And AI systems, if they're going to cause harm, will cause harm through cybersecurity. But I think eventually we're going to enter a world where we're going to have post-AGI cybersecurity, where AGIs are defending against AGIs. The transition to that period might be kind of fraught, where if you like make models more accessible, you're going to end up a lot of worm GPTs and stuff that cause a lot of harm. But I think there's going to be enough startups in AI cybersecurity such that the world is going to be more secure and lone actors won't be able to cause kind of like crazy 0 days all the time.
Right. You want your worst your worst case outcomes to be pretty well protected against.
Yeah. So I'm worried about the transition to that world, because that transition could have a lot of cybercrime, right? Because like you have to build the institutions and the vulnerability patching or something ahead of time. Because I do think, defense is fundamentally harder than offense, because you have to find all the exploits, whereas the attacker only has to find one. So that's one thing. But secondly, I think that fundamentally biosecurity, unless you have like the world is filled with like extremely intelligent, like adapting on the fly nanobot swarm, sort of like our immune system, but is like way more pervasive and is communicating between individuals and is worldwide coordinated. Like, unless you have something as crazy and sci-fi as that, biosecurity is like quite scary and hard and favors attackers a lot, I think. Certainly, like I don't walk around feeling terrified all the time, but I think that the COVID pandemic is like quite a scary thing for a lot of people, right? And I'm very glad that we had vaccines so fast, and I think that's important. But I think like we have huge gains to go in protecting the world from.
Well, and if that's a case in point, even if these engineered pandemics or engineered pathogens by either a misuse or a rogue AI system is responded to is only as bad as COVID and responded to as quickly as COVID, that would still not be a
It's
good
still
thing.
really bad.
We do not want people casually releasing COVID pandemics on the click of a mouse click.
Yeah. And I'll say, like, there are probably just extremely esoteric ways that malicious use of AI that's very powerful, or like AI accidents that run amok, right? They're extremely probably just crazy ways that these could affect society and be bad. I'm imagining like just viral, like I'm not confident that civilization is immune to really dangerous viral memes, you know, like socio-political viruses, you might call it.
Well, and we've already seen some of this with like misinformation bots of a really crude kind already.
Yeah. And I think the thing that's like I want to loop back to here is that open source models, like I mean, in my program, last cohort, in Jeffrey Laddish's stream, he's a hacker, former hacker, head of Palisade Research. So two of his scholars, for I think it was like $600 or less in like a few weeks, were able to RLHF, remove the safety restrictions from Llama 2 chat. And they weren't even like, I don't know, it didn't feel like it was particularly hard.
Right, it didn't take much money or really complicated engineering. I mean, these were two people over a summer, relatively junior researchers.
Yeah. I mean, props to them. Like, well done. Well done to Jeffrey. But this is scary. Like, if this is, and I don't see how any of the existing techniques that we have or that are like even in the pipeline can mitigate problems like this if you have access to the weights of a model.
Yep. Yeah, absolutely. That's a really good outline of the things that you're thinking about when you're thinking about making the world robust to a future with more advanced systems. It's not about not having the benefits. It's about ensuring that the baseline, you know, the worst case outcomes are well covered against.
Yeah, I think it's about like looking. The way I think about it is something more about like making civilization hardened against these things, because effectively we're putting a vast amount of civilization shaping power into many hands, some of which might be using it in ways that we wouldn't retroactively improve. And we can't predict in advance all the ways this is going to happen. And I think entering it with like overt optimism is very foolish. And we should like be taking steps to phase into it with protections and guarantees and as much reliability as we can.
Yep. I did a okay job at best at the beginning of kind of starting to talk about what the MATS program actually is, but I'd love to hear in your words, what is the MATS program? And yeah, tell us a little bit about what you guys are doing there.
Yeah, so the MATS program, as it's known, or the ML, Machine Learning Alignment and Theory Scholars Program, is trying to find researchers who are talented, motivated, and kind of critically bottlenecked in some way, and remove that bottleneck and get into the field of AI safety research. We're like not particularly focused on bias, discrimination, ethics, all of AI, all of which are very important concerns. But there are other programs working on them. We're trying to address a gap as we see it in the talent pipeline towards the kind of research that allows you to steer smarter than human systems and understand them, mitigate certain types of harms, just maybe even like deconfuse what these systems are and what they look like and what it's even possible to do.
Right, just to even understand what we're working with, because we're at a relatively nascent stage of the field with these advanced systems.
Well, yeah, I think so. I think like in terms of the technological maturity, I mean, like when I did my physics PhD, I was like building on such established research, right? This field had just like there are so many labs around the world that were doing my kind of research in quantum physics. There were like so many papers all the time that I could read that were always kind of like advancing the field in small ways. There was established practice of what kind of research was like what types of research should be pursued, et cetera. We have almost none of this with the field of AI safety, because the technology, this kind of like basically transformers, deep learning, either like hasn't been around very long, or people just weren't convinced that this technology would display the capabilities.
Right, people thought this was decades away or something like that.
Yeah, I mean, to the extent that like AI is like an old field, a lot of the capabilities that we're seeing right now are just it's this like exponential growth, it would seem, or at the very least, far faster linear growth.
No, and for people listening who are curious about this, and I'll put this in the show links, have a look at Epoch AI, and they have plotted a lot of the trends when it comes to deep learning, and there has been an acceleration over time, on how much money we're throwing at these problems, how much computing power we're throwing at these problems, how good the hardware that runs it is going. I think they may even have algorithmic efficiency on there. So yeah, things are moving, and they are moving very, very quickly, which means it's harder for all kinds of people to respond, including safety researchers, and as well as, of course, things beyond safety research like policy and governance as well.
Yeah, I think certainly the kind of governance problems that we're going to face are like I would wish we had decades more to solve, and the technical alignment problems as well. I think like it is very hard to robustly guarantee that frontier models, like I mean, we see all this stuff with the kind of like exploits, with the jailbreaking exploits and other types of exploits people can employ to frontier models, for which there don't appear clear fixes.
No.
And some of the like the types of exploits, like it seems like the adversarial attack surface is so large that we just don't know how we could ever patch it.
Also, there's just not the level of understanding to patch them. It's the surface area is large, and people are looking at a really inscrutable matrix of numbers, just a big box of numbers. And there's techniques, but these techniques look more like heuristics in a really early stage field, rather than, oh, we really understand what's going on here, therefore we know which knob to twist to stop this behavior versus prevent, keep this behavior.
Yeah, I think the bitter lesson is really applicable here. The things that like it's basically like why are AI models so powerful? Because very simple algorithms with a ton of data can produce extremely competent results. And this is just like I often think of it as like you're taking like some weird protoplasmic combination of cells or whatever, you're throwing it into some medium and you're letting it like spin for hundreds of millions of years or something closer to millions of years maybe, and then you see what comes out the other end. And if you're lucky, you can like prod it with like some sort of like crude probe throughout the training process. But you're often like I think what most of what you're doing is you're doing archaeology or something.
Right. You're just kind of looking at it from one tiny little bit of an angle rather than actually seeing it all at once.
Yeah, and you're kind of like we're kind of inferring the kind of processes, like the kind of attractors, only after the fact. And the thing I'm particularly worried about is that we build models that are powerful enough to like do a bunch of really complicated tasks, and we have reason to build them to be agents, to have capabilities to act autonomously in the world, and in the process of doing so, we haven't built enough safety guarantees, and we still don't really understand because these things are so obtuse, to know for sure that the goal-directed behavior that we've explicitly chosen, or that might even accidentally arise on the kind of tasks that we train models to be good at, is aligned with our interests. And I don't even know how I would if I could point a model that was like a powerful kind of optimizing model that was very goal directed. I don't even know what I would point it at.
Right. What values would you then try and imbue into that system?
Or what democratic institution would it report to? To effectively secure the world.
This is the example of what you're talking about with it would be nice if we had decades to figure this stuff out. Something that powerful and that complex, that thorny of a democratic or governance issue, you really hope you have time to be working on. Time and resources, people working on it.
I think there's a serious problem in pointing AI models at anything in particular at all, what I'll call corrigibility. I think there's a serious problem in, even if one person, or even if every United Nations state or something, or every company in the world had these models, how would the market or the economy of models not like the demon Moloch, right? Drive us to some weird futuristic brink, eating up all the free energy, just like rapidly, efficiently optimizing for some end, competing in some manner, maybe some races to the bottom.
Right. You really want to have good limits on these processes. Otherwise, yeah, it could even pointed in any particular direction, it could be really hard to know how that will end for us, and it'd be a positive thing for us or not.
Yeah, be it a unipolar world where there's like maybe only one very powerful model that, say, some future UN gets to employ to run in parallel many times over and like try and improve the welfare of the world according to some aggregated method. That seems extremely complicated. I'm not sure on Earth, like I have no idea how that would work. Or if there is, like, I see these models kind of amplifiers of human potential. Or alternately, if they're not in fact being directed by humans, they are amplifiers of their own.
Right.
Goals.
Some other set of goals, values that may be quite far from any human operator's intent.
Yeah.
So just to bring us back to the maths program, I know the temptation to talk about the inspiration for these problems or this initiative is large, and I do think this is important to kind of touch on. So you talked about maths being a way for researchers to get started. Let's just make it as concrete as possible. So who are the types of people, what stage are you hoping apply to this program? And once they're there, what does the program look like for them?
Yep. So the kinds of people we want to apply this program, I touched on it briefly before, but one, we want people who have engaged with the AI safety space, in particular, this kind of alignment field. There's a particular course I would point people to run by an organization called Blue Dot Impact.
Which we had Jamie Bernardi, a co-founder of Blue Dot Impact recently. So he was talking a lot about, I assume you're going to talk about the AI safety fundamentals course?
That's correct. The alignment course they offer. So that's like one almost prerequisite. We recommend everybody understand what they're doing before they jump into this field.
Right. So that's just a great first starting point.
Yeah, for sure. In fact, we recommend everybody, if they're going to like sink or swim, you know what I mean? Like you want to land in Berkeley for our program and understand what's going on. There's a lot of seminar talks and all of them assume you've done the entire AI safety fundamentals course.
And it's not a massive course. Like you can do this over the course of a few weeks, if you're motivated, even faster if you're really motivated. So yeah, just jump on it if this is something you're interested in. Okay, so you've done your AI safety fundamentals or equivalent. Then
number two, we want people who have some research experience or they're like proficient machine learning engineers or software engineers already. There are plenty of programs out there or self-directed study courses where you can gain this. Or I recommend just like doing a PhD. 80% of our scholars are current machine learning, current PhDs or
I didn't actually know it was that high within the maths program.
Yeah, so only about 10% are undergrads, and those are like pretty exceptional often. Certainly the cohort composition has changed as we've progressed, and it's become much more focused. We've been able to access a lot more of the higher end research talent of the last several cohorts. And then about 10% are like, postdocs or otherwise, working in industry. And I think this is pretty, this is pretty telling. Like, I think that conventional academic research labs have a huge amount to offer people. And it's possible that you don't have any research experience and you should apply to maths and you'd be like an amazing quick study. But I think research is often like kind of hard to learn. An exception might be like, it seems like software engineering in general, just some of the best software engineers I know, all self-taught, just extremely proficient at that. And they can like quickly boot up in that kind of capacity. But I think also I know a lot of software engineers who passed the program who talked about a lot of like struggles they had in adapting from software engineering to research.
Right. So research background of some kind seems to be, it's not a guarantee, but it's a pretty good indicator of enjoying and getting the most out of the maths program, would you say?
Yeah, I think we're not so much trying to build researchers as help researchers enter this new space.
Nice. Yeah, and I do know at least one math scholar who just came out of the last batch who she is an engineer and didn't do a PhD. So it can definitely happen. So it can happen, but maybe just be really open eyed about what you're getting yourself into. It is a research program. Is that fair?
It is a research program.
Right.
Yeah, you will be researching all the time.
Like publishing papers and things like that.
Yeah, we don't have a like requirement to publish papers or even write up your work, except via like an internal research plan and a presentation. These are the only two milestones. But we do strongly recommend that people, if the research they're doing is publishable, they publish it. And several mentors in the program are just very keen to like produce publications. Yeah. And I guess the third thing I'd say is because we are very strongly focused on the AI existential risk or global catastrophic risk, and ensuring that humanity is not disempowered, and just kind of like easing the transition into this world of transformative artificial intelligence, that we're particularly interested in people who are just very interested in furthering these goals.
Like specifically catastrophic and existential risk, as opposed to other smaller scope or more localized risks of AI. Is that what you're differentiating between?
Yeah, I think if people apply to our program and they're principally motivated about reducing like bias in the AI algorithms that are used for job hiring, that's not the kind of research that we cover.
Right,
and this is like focus. Great research and should be furthered, but there are plenty of academic labs that focus on this.
Makes sense. Fantastic. Anything else you'd like to highlight about the experience of the program? So once people get there, I guess, yeah, let's dig into a bit more of that. Like what should people expect to experience and also to expect to get out of it, the program?
Yeah, so it's a 10-week program in Berkeley, California, where we're sitting right now.
Yep.
It starts January 8th, runs through to March 15th in 2024. Currently applications are open. I don't know when this podcast is out. Hopefully they'll be
out in the next few weeks. So when do applications close?
November 17th.
Okay, we'll get this out well before those. So you've just given me a lot of motivation to get this out ASAP for you.
All right. Sounds good. Yeah. So November 17th, the way that the selection process works is the mentors on the website, matsprogram.org. The mentors almost all the mentors have like quite specific selection problems. And the idea there is a lot of the research is very differently flavored across the different mentors and streams for the program. So we have everything from, like I said, like understanding AI hacking, like and evaluating dangerous capabilities and all these dimensions, through to like, what do we do if we are just like trying to build safe AI using the tools we have at our disposal now and we can't slow down or something? Scalable oversight, other types of ways you might align language models, just lots of different things.
Lots of the different research directions that are out there when it comes to thinking about this risk.
Yeah, interpretability, either at a concept level or at the level of circuits, individual neurons. There's just like a bunch of research on understanding like the kinds of like we're putting up some new mentors now that are dealing with like developmental interpretability, based out of Melbourne, in fact. Which is like what kinds of like how does the kind of phase transitions, as far as we understand it, during training, how do they occur? Like,
how do these models suddenly get these capabilities somewhere in their training process?
Yeah. So second order phase transitions maybe are less sudden, but yeah, there's some like process towards emergent order. Yeah, it's just a fascinating problem. There's so many.
There's a lot of breadth in the MATS program as well. So I'm, and I've looked at it myself in the past. When you look at these different mentors, you may not be as interested in one or another or even most, but there's like one or two or three that you really gravitate towards. So I guess really looking at those mentors and their questions and the kinds of research they're doing is probably a good way to get excited about some of the work here as well.
I think so. I think the thing we're looking for, rather than like applying to like all these different streams, we really want to encourage people to apply to streams that they are fascinated by, because I think that's like staying power in research. If you're fascinated by a problem and you can actually tackle it, that's what keeps you in research for the long haul. And we're interested in helping people for the long haul or short haul. I mean, I'm not sure.
Yeah, and if it's the same as the last iteration, at least the way the application was structured last time, it really gives you a taste for the research as part of the application process. I remember each mentor's questions were actually quite strongly overlapping with what the work would actually look like. And so just if you think you're interested or think you might be capable, it's probably just best to just give the application a go.
Oh yeah. Get together with your mates, have a good day. That
Yeah.
Yeah.
No, I actually did apply to the last round of maths. Yes, I did not get in. It's okay. I'm not too hurt by it. I'm sure there were lots of really great applications, but honestly, hugely happy I did it because it was fun. It was fun to put together my application, and I learned a lot. And not getting into maths actually didn't stop me from continuing the work. Actually, I just went forward with more learning, and maybe in some future world where I have the time, I'll apply to maths again. But the point was the application itself was incredibly educational in and of itself. So big reason for everyone to try it. And if you do a good job with the application, then you're probably ready for the full program as well.
I think that's true. I think if you do well in the application, you should feel confident about doing well in the program. I think the questions historically have, we have new mentors this time, so we don't know for sure for them, but certainly historically doing well at the questions has been an extremely good tell for how well you do in the program.
Yeah. Would you hope so? That's a good application process. Yeah. Fantastic. In this world of alignment, I'd just be curious, this is just your personal take, Ryan. What do you think are some of the most promising research directions in this field of alignment in your view at the moment?
Yeah, it's kind of complicated. I think the median, conditional on us solving the alignment problem and building, safe transformative AI, I think the median way that happens is the kind of approach that the big labs are ostensibly taking, which is kind of interesting, with some caveats I'll make there. Certain other things I think have to go right for this to work on median. And that would be scalable oversight. So that is using models to supervise models. Like humans can't necessarily distinguish superhuman truths. Also, maybe humans have certain kinds of biases or shortcomings that models could exploit. So the idea is trying to scale models, human supervision of models through human assisted, basically AI assisted human.
Right, like having the AIs also as part of this training process of training these much more powerful
training models. Also evaluating as well. Right. So generation evaluation. And there's various schemes by which this might work, like having AI systems debate each other and use massively complicated concepts or whatever, but then this grounding out in concepts humans can understand eventually. And there's some intuition why this kind of thing might work. And that's that in a lot of there's various, as far as we know, arguments from complexity theory, right? Computational complexity theory, that certain types of problems are easier to evaluate than generate. But then, of course, other kinds of problems are hard to evaluate and generate as well. But it seems like a lot of the kind of tasks that humans do, a lot of research humans do, it takes a long time to conceive of novel, theories in science, but then relatively easier to design tests to disprove them.
Right. It's a good example is this recent superconductor release where people have been obviously working for decades across labs all around the world on trying to develop room temperature superconductors. And when a paper came out recently, or a preprint, whatever it was, of a potential method, tons of labs just immediately could just jump straight on that and go, let's try it. Does it work? Yes, no. And that happened in this space of weeks rather than decades. So that's a good example of verification is easier than generation.
I will say that question is still not quite yet resolved.
Totally sorted out, yeah.
But if the Manifold market poll is anything to go by, I think it's 4% chance.
Right, Manifold being a prediction market for this kind of stuff.
Which you can go and vote on for free, which is great. I think it's a lot of fun. Yeah. So I think that this kind of scalable oversight is part of the solution, the median solution. Other parts are putting humans in the loop in more novel ways as well. There's various schemes like recursive reward modeling that aim to address some sort of like generating training signals for models that, I guess are sort of super RLHF.
Mm-hmm.
I think RLHF
improvements in the direction, it's still RLHF. Oh, sorry, it's from human feedback, but it's new mechanisms for incorporating human feedback.
Yeah, I think the idea is to like have humans scalably contribute to aligning superhuman models. Because certainly there's this weird phenomenon, right? Like, so I mean, Jan Leike recently tweeted on Twitter that maybe they'll have evidence to display very soon that RLHF doesn't scale into super intelligent
He did
models.
actually tweet that. I did see that. That was interesting.
He did tweet
coming
that
from OpenAI. Jan Leike at OpenAI.
Yeah, who's one of the heads of the super alignment team. And so what's interesting to me is like this reinforcement learning from human feedback. Like even in theory, this should never work to like fully align superhuman models unless you're making some assumptions about how far human feedback generalizes. So let's say if you tell a model, be nice, be nice, be nice, be nice, every time you see it being mean in a way that you can detect. The question is, does that being nice behavior generalize to being nice in situations where you can't detect if it's nice or not? And I honestly think that this probably doesn't happen. I think that models misbehave in all sorts of weird and unexpected ways. And if we actually can't detect that, and our training distribution is not like it's not robust enough to the kinds of scenarios you might encounter in the world, or the kinds of like actions that models might take, such that like we have adequately, constrained the ability of models, with our training, then this is dangerous. This is scary.
And I think we've already seen some empirical stuff around this already. A good example was the Anthropic research around sycophancy, where they looked at models that had been trained with RLHF. They start to just tell you what you want to hear, rather than tell you the truth. So there were examples of it. As soon as you made any hint that you had one type of political alignment, the model would kind of change its answer to fit your worldviews. Now, that sort of thing, you could see why RLHF would reward that, because you're thumbs upping things. But very quickly, that then becomes a very unhelpful assistant in that case. But depending on what world effects this AI is in control of, it could be a lot worse than just telling you a mistruth or a false reality. It could be, creating a world that's actually quite terrible for that person or for the rest of humanity or something like that.
Yeah, sycophancy is a real problem, I think. Certainly we supported a lot of sycophancy at research at MATS under Owen Evans and Ethan Perez and Evan Hubinger last cohort, and continuing to do so this cohort. I think sycophancy is like very insidious, because basically what it's saying is like the model is doing what you effectively want it to do. It's like you, what's the classic example? Mickey Mouse and Fantasia. It's like, clean this thing. And then of course the runaway brooms and the spell that he's used runs amok and like basically causes way more collateral damage, that like made him, he should have said like, clean this place without like, doing all of these extraneous things that
and without and all these other constraints are the things that RLHF doesn't provide. It's just, it's a very simple signal, and there's not a lot of nuance here.
Yeah. I mean, I am actually kind of still somewhat receptive and open to arguments that RLHF might like generalize, like human level concepts like cooperation, kindness, or something like that. That RLHF might, or other types of like fine tuning. Where you take a model, maybe like you fine tune a data set of examples where it has to be non-deceptive or kind or something. I'm still optimistic that this can get us some of the way. I just remain quite pessimistic that we should rely on this for getting us all the way to super intelligent AI systems.
Yeah, and also, if this is what you believe, then this is a research direction. There's a bunch of experiments and things you can do to start to prove that this is actually the case. That there's safety research you can do in the direction of human feedback mechanisms.
Yeah.
Ryan, what are some things where you think, hey, there are some real serious gaps in kind of the current alignment ecosystem where people aren't working where they should be? Are there some that come to mind for you?
I think I want to kind of combine this with some of the intent of the last question, because there's way more, research directions that MATS supports compared to scalable oversight. And that was a more recent addition. I think the reason why we support so many research paradigms is because, well, one, certainly the recruiters at OpenAI and DeepMind and Anthropic are working very hard to try and hire competent software engineers who can help with scalable oversight and other, other kind of related stuff like RLHF, constitutional AI, recursive reward modeling, etc. I think that those things are meaningful. We can still help. Certainly, we seem to have helped Anthropic's team under Ethan Perez a fair bit with their
getting very talented
people in there. Getting great talented people into their getting great research published. But I think like we also there are like certain directions that are increasingly, I think, worth investing in. Obviously, you see a large focus on interpretability among the MATS mentors, be it mechanistic, that is like, the level of individual neurons or circuits, or concept-based interpretability at a very high level. And I think this is if we're to have serious safety guarantees about model capabilities and model goals, et cetera, you need these fields to grow.
You just can't be operating in a black box AI world. That just sounds like an unlikely safety.
I would feel more scared if that was the case.
Right.
And certainly there are like white box or gray box methods, like the kind of research Colin Burns was doing at Center for Human Compatible AI and now might be pursuing OpenAI, I believe, that are like opening up models and kind of just like training them on loss functions such that the model has to be like internally consistent. So if it believes I don't know, Rome is like doesn't contain the Eiffel Tower, it has to believe that the Eiffel Tower is in Paris, and that Paris doesn't contain, I don't know, some Roman.
There's going to be some different statements that all have to line up to be consistent.
Yeah, so you can open up models and you can like train them on. I don't know. You can like open up models and like maybe potentially design adversarial data sets that like target model vulnerabilities based on what you can exploit for having access to the internals of the model. You can also like freeze models and then like train against a frozen version of the model with a model that like learns to exploit the model's particular vulnerabilities. There's like all sorts of different things you can do. I think MATS's main role in the whole AI safety ecosystem is to continually adapt to the needs of the ecosystem and kind of pivot and be like this, very, very responsive, kind of agile, research pipeline. Such like when evals started to became increasingly, we became increasingly aware that evaluations might be very important, and that we actually had the capabilities technically to do useful evaluations. Matt started to like try and work very hard to promote this. We're working with Beth Barnes, and some of our scholars in the program were co-authors on some of the early papers out of ArcEvals before. Before ArcEvals was formed, we've been working with, Owain Evans on situational awareness, Ethan Perez on similar.
So are there particular gaps or needs in the ecosystem that you're jumping on now as part of MATS?
It's kind of hard to, it's interesting because like before we were focusing on, say, mechanistic interpretability, it seemed like relatively little was happening to grow the research field in terms of like active mentorship. There was certainly like a lot of great work happening. Like Redwood Research was running MLab and associated programs like Remix. But before Remix, after I think, I believe like sometime around the second MLab or sometime after the second MLab, like we talked to Neil Nanda now at Google DeepMind and who had left Anthropic before. And of course, like there's great work happening at Anthropic on mechanistic interpretability and the circuits agenda. And of course, Neil was doing like astonishingly good work on his own. And we're like, hey, Neil, how would you feel if we like tried to, scale this up? If you, it seems like you, everyone you work with,
a whole bunch more people working on interpretability with you.
Yeah. So we like put a bunch of effort into that. We have run several training programs and scholar cohorts with Neil. And now there's more mechanistic interpretability mentors as well, like Lee Sharkey, Alex Turner, Adria Garriga Alonso. And I think we've pushed very hard in mechanistic interpretability to the extent that like I'm not particularly scared about this field growing as compared to how I was before. I do think that a lot of people have kind of pivoted away from mechanistic interpretability in the alignment space more recently. It's certainly like something that's easier to get into based on like the technical requirements. Compared to some other more abstract
Are there some areas you think are notably underserved now?
Yeah, sorry. Yeah,
No, it's
I haven't
okay.
been dodging the question. I've just it's there's like
No,
there's
these
so
are
many.
good. I mean, these are good examples of what's kind of come before us. But I want to encourage us and our listeners to think about where it might be underserved still.
Yeah, I think a huge thing that like obviously Anthropic now is a team for this, but I think that um yeah, like kind of, and this is I'm not sure I want to advocate this research. I'm not sure even people can do this research. I certainly wouldn't want this research happening without extreme safety oversight. But the kind of research that I'm like particularly, I think is particularly bottlenecking us is knowing like what the shape of misalignment is. And I think people have called this gain of function research. That's a scary term.
So is this kind of like threat modeling, that sort of idea?
Yeah. So basically, the kinds of capabilities evaluations that you see, arc evals,
Right.
Apollo
This is like
research.
where Anthropic's been doing things. For example, with bioweapons for misuse might be an example of like seeing what that risk model looks like. That sort of idea.
Yeah, I think that there some of these research directions should not occur, um, like outside of very tightly controlled areas. But I think that like they need good people, and so I'm interested in helping support these
Good
particular
people
research
entering this
directions.
area of like evaluations and threat modeling, like or threat modeling, and then therefore the consequential evaluations you'd want on these frontier models.
Yeah, not anything for bio. I think that it like I mean Kevin Esvelt's lab at MIT has an interesting paper out democratizing dual use access to biotechnology. Sorry, the effect of AI on democratizing dual use access to biotechnology, and that's a very kind of I find that quite a chilling paper. You know, I think the kind of research I'm pointing to is understanding like the kind of stuff that Jeffrey Waddish's scholars are working on, the kind of stuff that ArcEvals does, like understanding like what current publicly available AI systems can do in sort of like a white hat kind of hacking manner. Um, and I think this kind of research is particularly important to understanding like convincing policymakers that these models can be a threat. And I think if you ask me like in a year or 2 years about this, I'd be like, man, people should probably chill out. You know, if things are proceeding apace or something, and maybe not do this too much. But I certainly think that demonstrating the ability for language models to hack systems is useful, both for the kinds of companies that I imagine are going to spring up very soon, right? Which are going to be like doing all kinds of fuzzing and auditing of security systems with AI tools. But also like is very important for securing civilization, but is also like particularly useful for tracking the capabilities of current models. So evaluating those capabilities, demonstrating certain types of capabilities, and I think demonstrating more abstract stuff like the situational awareness work that Owen Evans was recently doing. So this work is still like we might see some cool papers happening in this, but so much of this research is contingent on relatively few labs, relatively few groups. So I would definitely like to see more of this. And I think this ties right into concept-based interpretability work as well, which is like kind of approaching interpretability from another perspective, from this like large perspective. And there's a huge amount of like machine learning academics who probably could immediately pivot into doing this kind of research and understanding like the limits of model editing better. And yeah, just kind of like building really robust frameworks to.
So this is interpretability, but less on the mechanistic side and more operating at a higher level of abstractions that you might be able to extract from the model or recognize and manipulate in the model.
Essentially, yeah.
This is like the Rome paper, is it?
This is like the Rome paper, yeah.
Yeah, which I'll link to in the show links, but correct me if I'm wrong. The Rome paper was one concrete example where they took a model, I don't remember the scale of the model, and were able to actually edit a particular concept. I think the concept of whether the Colosseum was in Rome versus Paris, they were able to kind of edit that one fact and then see that the kind of the world model of the model actually changed. So it was a good example of interpretability and even editing.
Yeah. Yeah. I think this kind of research is very important and can urgently absorb talent in all sorts of conventional academic programs. And is also the kind of thing that might just like scale very well. Same as I think mechanistic interpretability might scale quite well too. Certainly we're like hoping that does. But I think like it's possible that we might need to do like the recent OpenAI paper where they like labeled every neuron in GPT-2, and like it wasn't perfect labeling, and it, you know, there's some reasons to think that the results aren't like GPT-2 isn't solved, you know what I mean, for sure. But like this kind of thing, like building up the toolkits and the understanding of the low level circuits that form in models and how transformers operate, is, I think, a necessary precursor to doing automated interpretability at scale of that mechanistic kind. So I think that's like pretty important to get right. If in fact, like this project at OpenAI as part of their super alignment team is to go well, like just more papers on the margin doing good mech interpret work is very important. Good concept-based interpretability work is also very important for evals and for all sorts of other, all sorts of other projects you could imagine, goal editing in models as well. I think also just understanding more about the kind of, understanding like both the process by which models acquire capabilities. So I'm hoping this developmental interpretability agenda uncovers some novel insights into, I guess, the inductive biases that shape models, and also helps us maybe like develop more robust tools to understand when models are likely to acquire capabilities they don't have yet, which would be crazy.
Right, which is very black box, very empirical at the moment.
Yeah. Developing some like maybe from, so a lot of the tools they're using are from like I guess I would say from physics, maybe from like studying, you know, ground states of Hamiltonians of like many particle systems and stuff. You know, that's where some of the intuition comes from.
Got it. So it has a lot of parallels to the world of physics. So if you're listening with a physics background, this might be an area to look into. And is this the same, correct me if I'm wrong, but this developmental interpretability.
Devinterp.com.
This is Daniel Murfitt at University of Melbourne, singular learning theory. Is that right? That's right. That world of research.
Yeah. So the research group Timaeus is Daniel Murfitt's the research lead, is the University of Melbourne. And Jesse Hoogland, a scholar in the winter program this year, is the executive director of that. So I think that's very important. Yeah, some of our scholars have gone on to do like quite excellent stuff in this space. Jessica Rumbelow, Leap Labs founder, was a scholar with us. They're doing interpretability. Apollo Research, also based in London. Founder Marius Hoppan, also the co-founder Lucius Bushnak. Several other people working there, Makita Valiency. A lot of researchers came through MATS, and we're very excited to support their projects. So I think, like I said, evals, demos, interpretability at both levels. Obviously, scalable oversight is a given, and more robust mechanisms for that too. And I think lastly, understanding like how to infer agent, like the kind of like agent structures in models, understanding like how to like processes like MESA optimization, how do these form? What is a MESA optimizer fundamentally doing? So this is like if you're in fact like GPT 3.5, it seems can play chess at 1800 ELO. That's crazy. No one trained it to play chess. How does it do this? Maybe it's doing some kind of something analogous to Monte Carlo tree search inside. Who knows? You know, maybe it's just like memorized a bunch of moves, but is really reliably interpolating between them in a way that's kind of crazy for a language model. But that's like an astonishingly good chess model when no one even tried to build it.
Right. So trying to better understand what's going on inside these models when it comes to their goals and capabilities.
Yeah, and the emergent capabilities as well. Both understanding maybe ways we can predict emergent capabilities, but also ways we can infer capabilities of models in new domains that we haven't yet tested them in by, inspecting the internals of the model. And hopefully this would be would help you fix certain situations where the model is fine until you deploy it some weird instance.
Right. Trying to catch things not just through, limited evaluations, but also through looking at the mechanisms and therefore being able to predict things like how will they do in an entirely new domain, what ML researchers would call like out of distribution type situations.
Yeah, I think people think of this. There's something here that builds into this So I believe this has been called by Buck or Paul Cristiano, worst case alignment. So I think some of the low stakes alignment solutions, such as ROHF, scalable oversight, et cetera, these are all contingent on the model, not like actively trying to subvert the training process. And certainly some of the mechanisms of a model trying to actively subvert the training process are like really giga-brained and complicated, like gradient hacking, where the model tries to actively modify its own gradient. You can only imagine it happening in a case where there's some sort of self-supervision, such as the kind of red teaming processes like scalable oversight likes to use. You can imagine a model might even corrupt its own training data, which is a scary thought. So I guess you also want to like have kind of guarantees such that if worst case alignment is in fact important, if models do acquire instrumental incentives towards deception or power seeking or something, that you have the tools to do to look inside the brain of the model, or to maybe like modify it a little. And as Buck Sudger says, make it a bit drunk, and then kind of give it a totally new data set. And maybe it's like, deceive, and you're like, wait a minute, you were hiding that before. So that kind of stuff would be great. And also tools to understand. The ideal thing would be like to have some ability to look at this enormous model and kind of work out what it actually cares about. And not just from behavioral data sets, like we're exposed to different outputs, but do something more mechanistic.
Right. Understand its goals from its internals, which is something very far from kind of where we're at today, but somewhere where we want to be. Yeah. Wonderful. Well, that was a big list, a lot of things. So a lot of areas for people to kind of look into as part of the MATS program, but even if they're not part of the MATS program, starting to investigate these areas and joining, either starting or joining existing initiatives to pursue these many research directions we want to pursue to better understand these systems and build a world that's more robust to kind of future advanced AI systems.
Yeah, and I should say there's a host of governance projects that I didn't even mention.
Right. We mostly focus on the technical side. Almost exclusively, and that's somewhat intentional. I think we'll have some governance folks talk about that as well. But for the MATS program, and correct me if I'm wrong, but the MATS program is more focused on the technical alignment side of things.
That's right. We have supported some few governance researchers in the past, but generally the focus has been more on the technical side.
Right. Any last comments or thoughts you want to leave our audience with before we wrap up for the day?
Yeah, I think that like AI is best understood as a technology that is an accelerant. And it's an accelerant could be accelerant of good things or of bad things. And I think if you have an accelerant, a thing you want to have in the world is some sort of decelerant or increased, security. We shouldn't assume that the institutions that have worked so far and the processes that have worked so far are going to scale into this new weird world. And I really encourage everybody to look into AI safety and consider if they might help with this emerging problem that I think is going to be the defining problem of this century, of maybe all time.
Possibly. And I think a lot of people listening to the show and the people working on it, like you and I, we definitely are convinced by this, and that's why we're working on it. Awesome. Well, thank you, Ryan, for kind of all of that incredible knowledge about what's going on in the world of alignment and teaching us about the MATS program. Thank you to our audience members, and we'll come back to you with other great guests thinking about this problem and thinking about how to make the world as positive as it can with these advanced AI systems. So thank you.